This is a second video about dilations. We're still hitting the same CCRSM standard, but this time we're talking about some other kinds of ideas that show up frequently on the PARCC assessment. Let's get started. The first idea is a reminder from Algebra 1 about the slope-intercept form of a line, which is in the form y is equal to mx plus b, where m is the slope and b is the y-intercept, or where the line crosses the y-axis. So we measure slope as the steepness of a line, as in the rise over the run. Okay? And we measure the y-intercept by, again, where it crosses the y-axis. So let's look at one or two of these. So in number 1, we are given y is equal to 1/4 x minus 1. The number in front of x is the slope, okay? It's the measure of steepness as rise over the run. The minus 1 is the y-intercept. So I tend to graph these first from the y-intercept because I know it crosses that point. Here it's -1. And then from there, I use the slope to determine the steepness of the line. For this one, for every 4 that I run, I'm going to rise 1. That's a point on my line. Okay? And I can't go any more, otherwise I'd go off the graph, right? So I'll go this way. I will kind of run backwards a -4 and then drop 1. And so that's another point on my line. So my line looks something like, okay, that has a y-intercept of -1 and a slope of 1/4. In number 2, the slope is this negative sign, which means the slope is -1. And the y-intercept is +2. So I start from the y-intercept at +2, and then the slope is -1. Now, as a fraction, we think of that as -1 over 1, so I can clearly see the rise and the run. Okay, so each time I run 1, I will rise a -1 or I'll drop 1. So I'm here. If I run 1, I drop 1, I'm here. And I'm here, and I'm here, and I'm here. And that's plenty of points to get an idea of what the graph looks like. So the graph looks something like, okay, that's a really quick reminder of how to graph an equation in slope-intercept form. So let's take those ideas and talk more about dilations. Here are some questions that have appeared on released PARCC exams. Okay. Number 1, in the coordinate plane, line L has a slope of 2 and a y-intercept of 0, 5. Well, we just reviewed this. The y-intercept is 0, 5. That's right here. That's the y-intercept. And the slope, they just said, is 2, which I think of as 2 over 1. So from that y-intercept, I will rise 2 and run 1, and rise 2 and run 1, and I can go back the other way as well and get a point here, and a point here, and a point here, and a point here. And I can draw this line right here. This is line L. Okay? Now, line R, that's a new line, is the result of dilating L by a factor of 3, which means the scale factor is 3, with center 0, 3. This is the center of the dilation. What is the slope and y-intercept of line R? Well, we've never dilated an entire line before. It's always been like a line segment or a triangle or something. So what we'll do is we'll dilate a couple of points on line L, see where they go, and connect them with the line. Okay? This scale factor is pretty big, and so it's going to get pretty large. So I'm going to pick some points that are very, very close to my center. I'll pick this point is pretty close, and this point is pretty close. And let's see where those points go. I'm going to name this point A and this point B just to give it some names. Okay, so to get from the center of dilation to point A, I'm simply going up 2. And multiplying 2 times the scale factor 3, I'm going to go up 6. Okay. okay? Because 2 times 3 is 6. So from the center, I'm going to go up 6, 1, 2, 3, 4, 5, 6, and this right here is A prime. Okay, now for point B, I went to the left 1. And multiplying 1 times the scale factor of 3, I get 3. So I'm going to go to the left 3 from the center. So I go left 3, and this point right here is B prime. And I will connect A prime and B prime with a line. Okay, the question is, what is the slope and y-intercept of line R? Well, luckily, I happened to choose a point that became the y-intercept. So it's pretty easy for me to read off the coordinates of that point, and the y-intercept is the point 0, 9. Okay, and reading off the slope, looking at this, again, picking some points, it's getting a little cluttered, but picking point B and point A, I'd have to rise 1, 2, 3, 4, 5, 6, and run 3, and so my slope is the rise number over the run number, which is 2 over 1, or 2. The slope is 2. Okay, let me point out, because it's right here, that notice that our slope didn't change. Okay, and that connects perfectly with the idea we saw in day 1 that we will get parallel lines. Okay, if the lines are parallel, the slopes are the same, but because it's dilated, we get a different y-intercept. There's one more new idea I want to discuss, and that is, if you have the pre-image and the image, how do you find the center of the dilation? Okay, and how do you find the scale factor if you're given the pre-image and the image? So in number 5 here, it says in the xy coordinate plane, triangle ABC has vertices, and then it gives you the vertices. Okay, and they didn't graph it for you, but they give you triangle DEF. Okay, so I'm going to go ahead and graph these 3 points and draw in triangle ABC. Okay, and that is triangle ABC. So the way that you find the center of dilation is you connect corresponding points. I would recommend that you do this with a ruler to be more precise. Okay, unfortunately, I can't stick a ruler very easily onto my smartboard, and so I'm just going to kind of follow slopes and hopefully get as accurate as possible. I'll connect what appears to be corresponding points, and hopefully they're concurrent. And they were. They were concurrent at the origin, okay, which is convenient for us. But even if it was somewhere else, I could still look at where they all intersect, and that's going to be the center of the dilation. So the center is at 0, 0 for this problem. Okay. Now, to find the scale factor, you can really do any corresponding length or coordinate. And what you'll always do is you'll look at the image, something in the image, over something in the pre-image. The important thing to know is it's always image over pre-image. Okay, so for example, I can look at lengths. Okay, this length right here in the image is 4, and the corresponding length in the pre-image is 2. And so I can look at 4 over 2 and see that the scale factor is a scale factor of 2. Okay, or I could have looked at this length right here as 6, and this length is 3, and also gotten a scale factor of 2. So you can pull off any corresponding lengths. Usually in these problems, there's at least one that's either horizontal or vertical, so it's easy to pick off. This video was a few more ideas about dilations that I wanted to talk about. Thank you for watching.